In this video, we are going to derive the expression for frequency modulated wave. Now, this is the message signal. This red color one, it's a message signal. And the green one is the carrier signal, carrier waveform. And the blue one is the resultant frequency modulated wave. If you closely look, when the message signal is going towards positive, the positive amplitude, this carrier frequency is increasing. And when it goes to the negative direction, negative voltage, the carrier frequency is decreasing. And if there is no message, then the carrier frequency is going to be the same. Now, today we will derive the equation for the frequency modulation. Now, this message signal is m of t. It can be represented as m of t, which is equal to am cos omega m t, or else we can write it as which is equal to am 2 pi f m t. This is the expression for message signal. Similarly, for the carrier, c of t equals ac cos omega c t, which is equal to ac 2 pi f fct. And the modulated signal, that is the modulated FM signal, I represent as S of t, which equals A cos theta. So this equation we should know. This equation A cos theta, I will number it as 1, A cos theta. The angular frequency, there is a relation, that is angular frequency equal to angular displacement upon time. So this theta is equivalent to omega t. Now, what is the next point? We know the instant or at each and every instant, the frequency of FM is varying with the message signal. So I'll write the instantaneous frequency. Instantaneous frequency. That is Fi. Fi equals, it always vary from the center carrier frequency or center frequency or the carrier frequency, that is Fc. And also it varies with respect to message signal. And there is a factor also. It is based on a message signal and a factor, this Kf. So this I'll mention, this let it be the second equation. Now I'll tell you what is Kf. Kf is the frequency sensitivity. Kf is the frequency sensitivity. That means variation in the frequency per volt. So with 1 volt of the message signal variation, how much is the frequency variation? That is what the Kf, that is the frequency sensitivity. Kf. Now How do you now we have to derive the equation for Fm. That's what we are doing. Okay. Now what we need to do, you have to, so what is should be your focus? We know S of t equal to a cos theta. So we have to find the value of theta in terms of frequency and m of t. Then we can derive the expression. So now, what is the instantaneous angular frequency? Instantaneous angular frequency. Angular frequency. So I will mention it as Fi, not Fi, sorry. We'll mention it as angular frequency. No, then it has to be omega I. Omega I is the angular frequency, which equal to what I can write? 2 pi Fi. Right, nothing wrong. It's same. Now what is theta? Theta we have written here. Omega equal to theta upon t. From this equation, what is theta? Theta equal to omega multiplied by t. Instead of omega, we can write it as 2 pi Fi multiplied by t. So theta also we got. Now let us differentiate with respect to t. And what do you get? D theta by dt equals 2 pi Fi. Right. Now from this equation, if you want theta, what you do? We'll integrate it. Theta equals, let the limits be 0 to t. 2 pi Fi dt, right, dt, Fi dt. So this equation, let it be the third equation. Okay. Now what we have to do? Put 2 in 3. We should know what is 2 in 3. Okay. Okay, theta value we have to put it in. Put 2 in 3. That means our instantaneous frequency, instead of this Fi, we have to put the instantaneous frequency. Let me write the equation what we got finally. That was the third equation. So theta equals 0 to t 2 pi Fi dt. This was our third equation. Now we are going to put Fi. This Fi value we are going to take from the second equation. So theta equals 0 to t 2 pi. What is Fi? Instantaneous frequency, that we got it as Fc plus Kf m of t dt. Let us put it in a bracket. This let be the equation number 4. Now we got theta. So what is our modulated signal? What was our modulated signal S of t equals this was the modulated A cos theta. This was the equation for the modulated signal. And now we have theta in terms of frequency, carrier frequency and the message signal. Now we will write it. S of t equals A cos, put the value of theta. What is theta? 2 pi (0 to t) fc dt. Plus kf m of t dt. Integration sign. Kf is a constant. M of t dt, 0 to t. Now there is one more factor comes into picture. One more thing comes into picture. This kf, we have to write this kf in terms of modulation index. For that, what was our instantaneous frequency? That is Fi equals Fc plus Kf m of t. What is this m of t? So Fi equals this Fc, okay? Fc plus what was Kf, let it be there. M of t equal to Am cos omega mt, right? When this cos omega mt becomes 1, we will get the maximum frequency. So instantaneous maximum Fi max equal to Fc plus Kf Am. So this cos omega mt becomes 1. Now we got a max value, Fi max value. Now what is the maximum frequency deviation? That is delta F. Delta F equal to Fi max minus Fc, which equals what was the value of Fi max? That is Fc plus Kf Am plus minus of Fc. Now this Fc cancels. So delta F equals Kf Am, right? Now if you want to write, instead of Kf what we can write? Kf equals delta F upon Am, amplitude of the message signal. So this also, instead of Kf, we have to use this delta F by Am to simplify this equation. Okay, now let's put the value. So what we can write? S of t equals A cos (2 pi Fc t) when you integrate it, plus instead of Kf what you are going to write? One more mistake we have done here. 2 pi is there, okay, right? 2 pi is there. So 2 pi, instead of Kf what we write? We will write it as delta f upon am. Now we are going to, okay, we have to write the m of t. What is m of t? That is am cos 2 pi fm of t dt. I think I'll write it in the next page. Okay. Now let's finish this equation. So S of t equals a cos 2 pi fct plus 2 pi delta f upon am. Now we are integrating. So am is a constant, we can write it outside. Am integration of cos 2 pi fm t, that is equal to sine 2 pi fm of t upon 2 pi fm comes down. Right, this is the integration. Now what is there? We can cancel this 2 pi and am cancels. So we can write the final equation as S of t equals a cos 2 pi fct plus delta f upon fm, frequency of the message signal, multiplied by sine 2 pi fm t. Here this factor, this delta f by maximum frequency deviation upon frequency of the message signal, this is known as beta. This is the modulation index. In detail, in the next lecture, I will explain to you all the basics of FM. In this lecture, we are only concentrating on derivation of the equation. Delta F upon FM is known as the beta, or this is the modulation index. Modulation index. Okay, so now we are going to write the final equation of the FM wave. A cos 2 pi fct plus beta, the modulation index, sine 2 pi fm of t. So this is the final equation for the FM modulated wave. Let me mark it. And before saying bye, we'll quickly revise once how I derived. So our message signal and naming we are done, and the modulated signal FM wave we have taken as S of t. Right, we have taken it as S of t. That is a cos theta. Then the instantaneous frequency variation of the FM we wrote. Then what is KF we told? It is a frequency sensitivity. Then we wanted the value of theta in terms of carrier frequency and the message signal. For that we have started from instantaneous angular frequency, and from there we got theta, and in that value we have put the instantaneous value of the FM, initially what we wrote. Then we have done integration and we have reached this equation. It is very simple. You have to. So I hope this is useful to you. If you like the video, please share with your friends.